All right, so now we're on part 3 of the fundamental theorem of algebra, and we're going to start off by just reminding ourselves of the factor theorem. Now, the factor theorem is something we talked about in a lot of detail earlier in the course, so if you need to see that again, go back and watch it. But essentially it says a polynomial f of x has a factor x minus k if and only if the equation f of k equals 0. So essentially what that means is when we find a 0, like we've done in these past 2 videos, we just get everything on the same side as the x, and that's going to be a factor of our original polynomial, guaranteed. So in example 18, we want to write a polynomial function f of least degree that has real coefficients, a leading coefficient of 1, and 2 and 1 plus I are going to be at zeros. Alright, so first off, least degree. Least degree means that we want the highest power to be as small as possible. Leading coefficient of 1 means that the number in front of the x that has the highest power is going to be 1. Everything else is really up to us. Alright, and we're given 2 of the zeros, but check it out. 1 plus I is a complex 0, and what we just saw in the previous video at the end is complex zeros always come in conjugate pairs. So 1 plus I is a 0, and its conjugate pair is also a 0. So 1 minus I is also a 0. Alright, so what I would suggest you do is start off, since we know these are zeros, so my zeros, just to sum up what we have, are x equals 2, x equals 1 plus I, and x equals 1 minus I. Now to get the factors, I'm just going to get everything on the same side. So my first factor is going to be x minus 2. This factor is going to be x minus 1 minus I. And this one's going to be x minus 1 plus I. I just get everything on the same side as the x to get the factors. Factors are always in parentheses. And what's nice is we know our leading coefficient is 1. So we're going to say, to get our answer now, we're going to say, and this goes back to what we were talking about, very similar to what we did with quadratics. We can just say f of x is going to be equal to our factors, x minus 2 times x minus 1 minus I times x minus 1 plus I, all multiplied together. Alright, so now what I'm going to do is I have to do some scratch work. I'm going to use the box. So I'm definitely going to start by using the box for these 2 pieces. Okay? This goes back to what you should have learned in Math 2. We have not talked about it in this class, so it's something you should have brought with you. Pay attention as we go. As always, though, if you just have no clue what I'm doing, be sure you pause, rewind, and ask questions as needed. Alright, so I'm going to set up my box, and I'm just doing a 2-piece by 2-piece. Okay, so I have x minus 1 minus I go together, because that's a complex number. The real piece and the I piece are attached. X minus 1 plus I, again, the real piece and the I piece are attached. Alright, so what I want to do now is just start multiplying, like I normally do. X times x, that's x squared, no big deal. Now I have x times negative 1 plus I. That's kind of like distributive property, so really when I clean it up, I get negative x plus I x. Okay? So that was my scratch work right here. When I do the same thing here, I have x times negative 1 minus I. Again, I'm putting it in parentheses because there's more than one thing here. Now distributive property, so negative x minus ix. Okay, and again, this was scratch work right here. And now, probably the more challenging thing is I want to multiply these 2 complex numbers together. So what I'm saying is negative 1 plus I times negative 1 minus I. Well, fortunately, our calculator can do that part for us. Since it does not have an x, our calculator can do that part for us. Again, since you see the I, you want to make sure you're in A plus BI mode. I'm already there. Now I'm just going to type it in exactly the way it looks. Negative 1 plus I times negative 1 minus I. Multiply together, and I get 2. So all of this together, when it combines, is just a 2. All right, now I want to combine terms wherever I can. So check it out. I have x squared. That's the only like term. Now, negative x and negative x. That's negative 2x. Now I want to combine my I-x's. But negative ix and positive ix, these two pieces are actually going to cancel out. So that's convenient. And then I have just regular 2, just falls down. This is still going to be multiplied by the piece I haven't used yet. So x minus 2. Alright, and now I'm going to do my box again. This time I need a 2 by 3 box. So 6 squares inside. So x minus 2, x squared minus 2x plus 2. So I have x cubed minus 2x squared plus 2x, negative 2x squared plus 4x minus 4. I want to combine my terms wherever I can, so I have f of x. Again, I'm figuring out my polynomial. F of x is x cubed minus 4x squared plus 6x minus 4. Well, I have my polynomial of least degree. I had 3 zeros that were given to me. 1, 2, 3. So my highest power is 3 by the fundamental theorem of algebra. That makes sense. Okay, and said my leading coefficient is 1. That's always the number in front of the x that has the highest power. That's true. So everything's done. I've created my polynomial. So in the past 2 videos, what I've given you before was this polynomial, and you had to figure out what the zeros were using graphing and synthetic and long division. This time we're working backwards. I gave you the zeros, and you had to multiply those together. Yeah, it was kind of messy because we had the i's, but no big deal. Take it baby steps. And you generate the polynomial that has those zeros in it. Okay, so that's it. Let's move on to the next example. In example 19, we want to write the cubic function whose graph is shown. Now, first off, we're looking for the zeros, okay? Just like we did in the previous example. The zeros is just a fancy name for the x-intercept, so I have x equals negative 3, x equals 2, and x equals 5. Again, I'm just getting those from the x-intercepts. Now, I want to turn each of those zeros into a factor. I'm going to do that by getting everything on the same side as the x, like we just did. So the first factor is going to be x plus 3. Next factor is going to be x minus 2. And the next factor is going to be x minus 5. I know these are all factors of my cubic function. So cubic means degree 3, like we just created. Okay? These are all because they're 0. At these values of x, if I plug into the function I want to create, the y value of the output is going to be 0. And the factor theorem that we just went over and we talked about many chapters ago says when you plug in an x value, plug in a 0, and your output is 0, then it has to be a factor, okay, when you get everything on the same side. So now, since we don't know anything about our leading coefficient, we're not told that, we have to kind of modify. So I'm just going to call this f of x. And I'm going to put the number a here. Okay? That a represents our leading coefficient. So before, I did not need a because I knew the leading coefficient was going to be 1 if that was told to us. Here it's not told to us. So I'm going to put a, and it just represents our missing leading coefficient. We'll figure out what that is in just a moment. But now, like I did before, I'm going to multiply my factors together, just like we did in the previous example. Okay, so I want to start by doing some scratch work, and I want to use the box multiple times. So I'm going to start off by saying just x plus 3 times x minus 2. That's going to be a 2 by 2 box. Okay, so I have x squared plus 3x minus 2x. Minus 6. I want to combine my terms, so I end up with x squared plus 1x minus 6. That still needs to be multiplied first off by a on the outside. So we're still talking about our polynomial function. Is equal to a times what we just came up with times x minus 5. We haven't done anything with that yet. Okay? So now I'm still doing some scratch work. I'm I'm going to multiply these two pieces together using the box. This time I'm going to need a 3 by 2 box, so it's got 6 squares on the inside. So I have x squared plus 1x minus 6, x minus 5. Now I'm going to multiply these together, so I have x cubed plus x squared minus 6x. X squared times negative 5 is negative 5x squared, negative 5x, and then 30. All right, I'm going to combine like terms wherever I can. So x cubed, negative 4x squared, negative 11x plus 30. And I'm still multiplying that by a, because that's my f of x. All right, well, now we're ready to figure out what a is. First off, instead of f of x, I can call it y. So y equals a times x cubed minus 4x squared minus 11x plus 30. And what I'm going to do to find a is I'm going to pick at least one other point that's given to me on the graph. This 0, negative 15. So this is going to be my x, this is going to be my y, and I'm going to plug in. The only thing that's going to be remaining is my a. So I have negative 15 equals a times 0 cubed minus 4 times 0 squared minus 11 times 0 plus 30. I want to clean up wherever I can. All of this on the inside, 0 cubed minus 4 times 0 squared minus 11 times 0. That's going to be 0. The only thing left over is going to be 30. So negative 15 equals 30a. Now I want to get a by itself, so I'm going to divide by 30. Cancel out. So a is going to be negative 1/2. And now that I have that, I can go back into my function. I'm just going to keep it y equals, why not? So y equals negative 1/2 x cubed minus 4x squared minus 11x plus 30. Now, to check yourself, since we're given a graph and we know several of the points on this graph, I can actually put this in y equals. Remember, every fraction needs parentheses on it. So what I'm going to do now is go to y equals, clear it out. So negative 0.5 parentheses x cubed minus 4x squared minus 11x plus 30. Graph it. Now, I don't really care about the picture of the graph. However, if you want to compare it to the picture that we were given, might not be a bad idea. It looks really similar, so that's a good sign. But what I'm most concerned about is going to my table and checking, make sure I hit these points. So second table, I know at negative 3, I'm supposed to get a 0. I do. At 0, I'm supposed to get negative 15. I do. At 2, I'm supposed to get 0. I do. And then finally, at 5, I'm supposed to get 0. I do. So what we've shown is by knowing what the zeros are and how to get our factors, we're able to generate our polynomial function. And by using at least one other point, we can figure out this leading coefficient a, which is what we need, and that's going to finish us off to create the final form of our polynomial function. And that's it for the fundamental theorem of algebra. Again, it was a 3-part series, lots of information, lots of hard algebra. I know it's difficult, so go back and watch some of those old videos for a refresher, ask questions, get help. Let me know if I can help.